Okay, hypothesis test for a population proportion. So now we're going to have those proportions in their fractions. It says, a hospital claims that the proportion P of full-term babies born in the hospital that weigh more than 7 pounds is 35%. In a random sample of 245 babies born in the hospital, 103 weighed over 7 pounds. Is there enough evidence to reject the hospital's claim at the 0.1 level of significance? So, their claim, whoa, as I throw that on the floor, is that they weigh more, or that the hospital that weigh more is 35%. Right? That's the percent or the proportion. So when we check this one, we're going to say, is that P really equal to 0.35, or is P not equal to 0.35? I can tell when it asks if it's a two-tailed test instead of a one-tailed test that it should be the equal and the not equal. That'll give you a hint there instead of being a greater than or a less than where you have the one-tailed test. Just a little hint in there. So when we do a population proportion, we are going to do the z-test. And our formula for our test statistic is going to look like this. P hat, which is the sample proportion, minus P, which is the given proportion or percent, over the square root of P times Q. Q is going to be the opposite, or the complement of our P. We'll get to that, over N. All of that's underneath the square root if I can read my writing. So, on this one, P hat is your sample proportion. Our sample proportion here says that we had 103 babies out of 245. Now, if that comes out to a nice decimal, you could change it to a decimal. I just used the fraction when I typed it in, but let's go ahead and check, does it come out nice or not? If you take 103 divided by 245, do you get a terminating decimal, or does it just keep going? It's a long one, so then we probably have to use the fraction just so we don't get rounding errors. Okay, P is going to be the percent we're checking against, which is the 35%. Q then is going to be 1 minus P. So I'm going to take 1 minus 0.35, which is your complement. If I have 35% here, the opposite of 35%, or my complement, would be 65%. Yep, 0.65. So Q is going to be 0.65. What else do we need? We need N. N, how many people did we have? We had a sample of 245 babies, right? All right, so we want, for our formula, 103 over 245 minus our 0.35, all divided by the square root of 0.35 times 0.65 over N245. When you punch it in your calculator, it should look something like that. The screen looks a little fuzzy, doesn't it? Yeah. Let me push the power cord back in. Usually is that loose. That help any?
Yeah. Okay. Do we do this?
All right, so get on the calculator, clear that out. Okay, we want 103 divided by 245 first. So we're not going to do any of those tests yet. That's coming later. We're just going to do our calculation. So 103 divided by 245. Then on the other, whoops, 245 was our number. Got 25 in there. Okay, click on the side of that. Yep, over to the right. There you go. We want minus 0.35. We're gonna, whoops, just have to hit undo there, or backspace. Okay, now we're gonna highlight all of that because all of that's on the top of my fraction. And then we're gonna put divided by square root. And under the square root, we want 0.35 times 0.65. I'm not sure if you need to highlight this or not before you do the dividing. I would do it just to be on the safe side. Highlight the 0.35 times the 0.65. Nope, I don't want it like that because I want the square root over the whole thing. See, nope. Undo. Try to highlight it without the square root. There you go. Now put the divide by. There you go. There's how we want it. 245 on the bottom. All right. See how it looks like kind of what we wrote down? All right. So we get a test statistic of what?
2.31.
We're going to go to 3 decimal places, so 2.311. Okay, 2.311. Now this one is doing critical value. When you do the critical value, you're using the sub. But because this is a two-tailed test, and our total level of significance is 0.1, we have to divide that by 2. So we're going to take 0.1 divided by 2 and use 0.05. Each side is 0.05. So when we do our critical value, that's when we're doing the z sub something. Z sub 0.05. So when it asks for the critical value, we did the t-test, we did t sub something. If it is z-test, we're doing z sub something. If it's a one-tailed test, we would just use this number. If it's a two-tailed test, we have to divide it by 2. And so when we do that, z sub 0.05, we don't have to have a degree of freedom since we're doing the z-test. We get what number? So if this number is 1.645, then this number is going to be negative 1.645. Okay? So we want negative 1.645 and positive 1.645 for our critical values. So when we test our critical value or test our point, we're trying to find, does this test value, where does it fit in that section of our graph? Where would that number be? Would it be in the first section? Would it be in the middle? Would it be in the last section? If I have 2.311, where would that fall? It's going to be in the last section. 2.311 is in that last section. That last section is the not equal to part. This is going to be the null where it's equal. This section is going to be your H1, and so is this section over here since I'm doing does not equal. It falls in the H1 section, right? So this is going to be my true statement. This is going to be my not true statement. It doesn't fall in the middle. It falls on one of my two ends. So, can we reject the claim that the proportion of full-term babies born in the hospital weigh more, or that weigh more than 7 pounds is 35%? Can we reject the claim? Is it equal or is it not equal? It's not equal, so yes, we can reject the claim. It's not true, right? We're saying it's not equal, so yes, we can reject. Somewhere in there it says, can we reject the claim? If it would have said, can we accept it, we would have said, no, we can't accept it. It's not equal to 0.35. It's not. Equal, that's right. So can we reject it? Yes, it is not equal to that 0.35. It doesn't land in that middle section. All right, so number 5. Let's see if I find number 5. I'm trying to do 6. A presidential candidate's aide estimates that among all college students, the proportion P who intend to vote in the upcoming election is at most 65%. If 193 out of the random sample of 265 college students express an intent to vote, can the aide's estimate be rejected at the 0.5 level of significance? Perform a one-tell test. We're doing a one-tell test because we're using the word at most 65%. What inequality symbol would be the at most? At most is which symbol? If this is the most, I'd have to be less than or equal to. So my question is it less than or equal to 65%? Since that has the equal to, that's my null hypothesis. Is P less than or equal to 65%? Which means my alternative hypothesis would be what? Is P greater than 65%, right? The opposite of whatever I have for that one. But the null always has the equal. So if they use the word at most or at least, those are going to have the equal sign in them. Okay. Since we're doing a population proportion, we are going to use our z-test. And so, we want the P from the sample minus the P that we're comparing it to over our crazy square root, which they say is P times Q over N. So, the P from our sample, P hat is what they call that. I don't know why they call it P hat, just because that looks like a hat. I don't know. P hat. My proportion from my sample is yep. 193 out of 265 is what they tell me. Again, let's try to see if that comes out halfway decent or is it a great big long decimal.
It's a good one.
All right, then we'll use the fraction. Our regular P is what we're comparing it to, 65%, right? Our Q then. Q is 1 minus P. 1 minus 65% would give me 35%, right? Yep, so 0.35 is our Q value. And our N value, N is 265, right? 265 were sampled. All right. So, now the trick to get it into the calculator. 193 over 265 minus our 0.65 all over the square root of 0.65 times 0.35 over our 265. Yep. Did you try that one yet, or are you taking the word for it?
All I
On there, you have to hit a bunch of equals in there. So if you're doing it on that calculator, you would do the 193 divided by the 265 minus the 0.65, which is all on the top of the fraction. Then you'd hit equals. Then you're going to take that answer, so you're going to hit second function answer, and you're going to divide that by square root, so you do second function and the x squared to get the square root, and then you do 0.65 times 0.35, and I don't think you need parentheses. I think you can just divide by the 265. We're going to find out. And hit equals. There's our number, right? So you do the top, hit equals, and then do the answer divided by the bottom. All right. We are doing a one-tailed test. Our one-tailed test says we're testing less than. We are going to find the p-value. Now when you do p of z on the Alex calculator, it tests which direction? P of z is greater than, right? P of z is greater than on the Alex calculator. Since we're trying to test less than, we have to do the 1 minus in front. 1 minus p of z is greater than, because we want the less. And the Alex calculator does the greater. 2.672. So you have to keep in mind that when you're looking at that Alex calculator, which way it's testing. Most of the tests are all greater than. If you're doing less, then you do 1 minus that.
Is it this P? This one?
1 minus p of z. Well, we're going to do, yes, it is that one, and we're going to do 1 minus that. 1 minus first, if we want to put it all in at once. Did you get that number already? 1 minus p of z is less than or equal to our test value 2.672 equals, there we go, that's the right number. Did you figure that out? Yours is kicking you out.
So it's, we're going to do
So we
one.
did 1 minus, and then the p of z, yep, and then our test number 2.672. And hit equals. So, that number 2, 3 decimal places, is 0.004. 0.004. Again, this is a percentage. We're comparing this percentage to the critical value. Here's the critical value. So, if I have 0.004, is that less than or greater than the 0.05 that I'm testing? If it's less than, now we're back to thinking. If it's a less than, do we accept the null or reject the null? Look at your notes. Guess again. If it's a less than, we reject the null. If it's a greater than, we accept. So what we're saying is the percent we got is that it's only a 0.4%. 0.4% is less than 5%, so we can't say it's true. It's not big enough, right? I want my percent that I think it's true to be higher than the percent I'm testing it at. So this percent is not greater than this percent. We can't accept the null. So that means this is not true. This is true. That statement's not true. The bottom statement is true. So can we reject the aide's estimate that the proportion of the college students who intended to vote is at most 65%? Can we reject that? That's the hard part, trying to decide yes or no, isn't it?
Yeah.
I know. So, we are going to reject the null. We're saying this is not true, so this is true. We're saying P is greater than 65%. So can we reject that it's at most 65%? Yes, we can, because we're saying the other thing is true, right? So yes, we are rejecting that first claim. We're saying that first claim is not true. I know, it'll take some practice. It took me a while to figure it out, for sure. All right. Number 6. A psychologist specializing in marriage counseling claims that among all married couples, the proportion P for whom her communication program can prevent divorce is at least 77%. In a random sample of 220 married couples who complete the program, 165 of them stayed together. Based on this sample, can we reject the claim at a 0.01 level of significance? Perform a one-tailed test. We know if it's a one-tailed test, it's going to have the greater than or the less than, not the not equal to one. So, the claim is it's at least 77%. At least, that's another one of those, at most, at least, all those. If it's at least 77%, at least 77%, what inequality symbol represents the word at least? Greater than or equal to, right? If I said you gave me at least $100, you gave me $100 or more, right? At least 77%, we're going to say greater than or equal to 0.77. Again, because that does have the equal, that's our null. P is greater than or equal to 0.77. The alternative there, alternative one is P is less than 0.77 then. Again, since we're doing a proportion, we're going to use the z-test when we do our test statistic. And then we got to use our formula. So, P hat minus P over the square root of P times Q over N. P hat, our sample proportion, is 165 over 220. P, the percent that we're comparing it to, is 0.77. So Q is going to be 1 minus 0.77, which is going to be 0.23. I'm trying to write the 3 first. 0.23. And N is going to be 220. So we're going to take those numbers, plug them into our formula. 165 over 220, I'm not even going to worry about if it comes out nice. We know how to get it typed in. Minus 0.77 all over the square root of 0.77 times 0.23 over 220. Yeah, negative what?
0.705.
Yep. Negative 0.705. All right. So, on this one, the H1 section is the less than. Right? So what we're doing is we're checking the left side. We're doing the left-tailed test. This is our critical value. When it ever asks it for the critical value, that's when you do the sub. So we're doing Z sub, but we want the answer to be negative because we're doing the left side and not the right side. So we're going to do negative Z sub point, what was it, 0.1. Again, if it was a two-tailed test, we would divide it by 2, but since it's a one-tailed test, we use that number. If we're texting to the left, we use negative. To the right, we want a positive number. So you're just going to do negative Z sub 0.01. Negative 2.326 is what you got? Okay, so that means that this dividing part is at negative 2.326. We want to decide what section our test value is in. Is our test value less than or greater than that number? The test value is greater than that number, right? The negative 0.705 would fall in this section that's greater than, which means this is the true statement, this is the not true statement. So now the weird question at the bottom. Can we reject the psychologist's claim that the proportion of married couples for whom her program can prevent divorce is at least 77%? Can we reject this claim? No, we can't. That's the true statement, right? So no, we can't reject that. That's the true one. All right.